Hey, what's up guys? So it's time to nerd out a little bit more and talk about computer processors. If you haven't watched my other video about RAM, I think it's good to watch before you watch this one, and you can just click this link right here and check it out. So what do most people know about computer processors? Hey, yo, check out this new computer processor I got, man. It's like 10 cores and it's like 40 gigahertz each core. No way, dude. That's so fast, man. You're so lucky. Alright, if you guys are a little curious about how these mysterious processors work, you should continue watching this video. All the concepts are relatively simple, intuitive, and easy to understand, and I'm going to explain them to you in less than 5 minutes, so let's do it. The first thing that you have to understand is what an instruction set architecture is. And I know this sounds really complicated, it has the term architecture in it. What the hell? Let's break it down. An instruction set architecture is a well-defined list of instructions that the computer processor must understand. That was a mouthful. Let's take an example. My name is Chef Dave. I have a particular set of skills that I've acquired over a very long career, skills that make me a nightmare for fruits and vegetables. A chef is just like a computer processor. Pretend I'm a chef. I'm responsible for a particular set of kitchen and cooking skills. If we made a list of all the cooking and kitchen skills, cutting, chopping, stir-frying, sauteing, and we compiled a huge list of all those skills, that would be called a chef instruction set architecture. We can just call it Iron Chef instruction set. The Iron Chef architecture, which includes things like cutting and chopping, a computer instruction set architecture might include instructions like adding or multiplying or computer type things, but you don't have to worry about those. You know, I'm a respectable chef. I'm able to do everything that's on the Iron Chef instruction set list. I can do all those things, no problem. If I'm a chef and there's a million instructions that I have to be able to do, if I can't just do one of those instructions, I'm useless. Pretend if I can't do cutting, I'm a worthless chef. A computer processor has to be able to execute every single instruction in any particular instruction set. If you tell a computer processor to do 1 + 1 and it says 7, then it's probably less useful than a brick. Okay, so hopefully you're getting the gist of what an instruction set architecture is. Just think about chefs. Sometimes in nerd lingo we abbreviate it as ISA, so if you want to sound smarter you can say, I know what an ISA is. Actually, you should never say ISA, forget I said that. In your desktop computer and a whole ton of desktop computing for the past decades, they followed this instruction set architecture called x86. In a lot of mobile devices, like your smartphones, they have special processors which implement an instruction set called ARM. If you run into those terms, you'll know what they mean. Alright, let's talk about processors a little bit, not instruction sets. So this is a really important point. Multiple processors can implement the same instruction set. So instruction sets don't change as often as processors do. You know, back in the day when Intel came out with Pentium 1, 2, 3, 4, 5, 6, 7, all those Pentiums were actually implementing the same instruction set. So as I told you before, I'm a respectable chef and I can do all the instructions in the Iron Chef instruction set. But I'm not the only one that can do them. If we go to the Food Network and call on Iron Chef Morimoto, he too can do all the instructions in the Iron Chef instruction set. He can do everything much better and much faster than I can. Not all chefs are created equal and not all processors are created equal. The reason why there's so many processors that are released every year is that each one outperforms its predecessors. They do the same instructions, but the newer ones just do them better. Okay, so what exactly is a computer program? You can think of a computer program as a complicated chef's recipe. If you're trying to make a fancy Italian entree, you can break down that recipe into a very specific set of instructions that might all be a part of that Iron Chef instruction set. So any person like me or Iron Chef Morimoto that can execute the Iron Chef instruction set would be able to make that Italian entree given the recipe. All a computer program is a huge list of instructions that are part of a computer's instruction set architecture that the processor can understand. Alright, so you buy a new processor and it's like 2 gigahertz. What the hell is a gigahertz? Hertz is how we measure the speed of a processor. Hertz is also a measure of frequency. Frequency is exactly what you think it is. It's how often something happens in a particular amount of time. That's it. 1 hertz is 1 cycle per second, and 1 gigahertz is a billion cycles per second. As we said before, not all processors are created equal. Processor A might take 10 cycles to execute one instruction, but another processor can do the same instruction in only 3 cycles. So which one's better? So a slower processor, but it perhaps could be more efficient with its cycles, could potentially outperform a faster processor, which is really fast, like 10 gigahertz, but it's super inefficient with its instructions. Alright guys, so that was some basic processor concepts. Thanks for your time, and I hope you enjoyed the video and you learned something. Remember, never say ISA in real life, or else you will be a douchebag. Peace out.
The microprocessor extends the intellectual capacities, the brain power of human beings, thus extending the human reach. My name is Federico Faggin. I was the person in charge of the development of the MCS4 back in 1970, 1971 at Intel. The MCS4 was the 4 chipset that was developed for Visicom. One of the chips was the 4004, the world's first microprocessor. When I joined Intel, the first major challenge for me was to devise the methodology that I was going to use using the silicon gate technology, which was also a new technology. That technology allowed to make complex circuits in a different way than metal gate, because nothing like that was done before. I had to figure out how to do it. Ted Off, with the help of Stan Mazer, was able to define an architecture for a CPU that was much simpler and faster than what the customer wanted. The customer wanted a CPU that was special purpose and was supposed to be integrated into 3 separate chips. By using dynamic memory instead of shift register memory, Ted Off was able to reduce the complexity of the CPU so that he felt that it could be built in a single chip. The second defining moment was when the 4004 actually worked. In the middle of January, 40 years ago, when I was alone in the lab of Intel debugging and testing the chip and finding that it was completely working. That to me is when the 4004 was born. The microprocessor extends the intellectual capacities, the brain power of human beings, thus extending the human reach. The significance of the microprocessor is really in having enabled the